So this is just continuing from yesterday. So example 4, it says solve the system using elimination. It's the same steps as you saw before, but it's going to involve this step 1 a lot more often, okay? Where you have to multiply one equation or both of your equations to be able to eliminate something. So look at this letter A here. Do you have a variable right now, your x's or your y's, that if we added or subtracted, but typically added our equations together, it would go away? That means these would have to be opposites, right? 3 and -3, or 4 and -4, or these would have to be opposites, 2 and -3, or 2 and -2, or 3 and -3, okay? But they are not. So that's always where you want to start. Like, could I just do it right now and be done with it? If you can, great, do it. But we can't on this one. So then the next question that you should ask yourself is, can I multiply one equation to make it that way? So then you look at what you've got. Could I make a 3 a 4 or a -4 very easily? Not really, right? Could I make a 2 a 3 very easily? Not like, yeah, no. It would be a decimal, right? Or a fraction that you're multiplying by. And that just requires more work. So if you cannot do it very easily to one equation, then you have to multiply both of them. And I would say the easiest way, if you're going to multiply both of them, is to just pick a variable that you're going to work with and multiply it by the other number. Sometimes you don't have to go that route. You can go like smaller numbers than that. But if you're looking for just the easiest route to figure out what it should become, you can always multiply like this number by this equation and this number by this equation. The only difference is you have to think about positives and negatives, okay? Because we want to eliminate and we want to add them together. So I'm going to turn my y's into what number to make them both the same?
3.
6, right? If I multiply this top one by 3, I'll get a 6y. So do I want to get a 6y down here? I want to get a -6y. So if I want that to be a -6y, what do I have to multiply the whole thing by? -2, right? To turn it into a -6y. So that's what we're going to do. We're going to multiply our top equation by 3. We're going to multiply our bottom equation by -2, and then we'll simplify. So let's do that. And here's the other thing that gets done wrong a lot. A lot of people distribute like this, but they forget that there's that 1 out there. You have to multiply that by 1 as well, okay? So I'm just going to write 2 new equations. My first one is going to be 3 times 3x, so 9x. 3 times 2y is 6y. And then 3 times 1 is 3. Does everyone see how I got that top equation? Ask me now if you have questions. Okay, then your bottom one, we're going to do the same thing, but we're multiplying everything by -2 now. So this is -2 times 4x is a -8x. -2 times 3y is a -6y. And -2 times -2 is a +4. They're so loud. This happened during my study hall last time, so I didn't notice it. Okay, now what we do is we add these 2 equations together because now we can eliminate our y's. So if we add 9x plus a -8x, what do we get? 1x, right? So you can just call it x. If you want to put the 1 in, go for it. 6y plus a -6y is 0. That goes away. 3 plus 4 is a 7. Look how nice this one is. We know our x value already. There's nothing to divide by. X is 7, okay? So that's the first part of it. X is 7. But we're not done. What do we have to do now? Have to plug it in. Now here's the deal. How many different equations do we have right now that are true for this problem?
4.
We have 4. Which one are you going to plug the 7 into?
3x plus 1.
Sure. Could you plug it into the other 3? You may pick whichever one you want, okay? So if we start with the top one, it would be 3 times 7 plus 2 times y equals 1. So 21 plus 2y equals 1. Take away the 21. So you get 2y equals negative 20. And then divide by 2. Y is negative 10, which means our answer is the point 7, negative 10. Isn't that so fun? I love elimination. I love it so much. Questions on that? Okay. I have to write a little smaller on this one. I didn't give you guys a ton of room there, did I? Sorry. Look at letter B here. You're gonna want to zoom in a little bit so you don't run out of space. Do you remember the first thing that you should check?
If it's like possible to do.
If it's possible to eliminate right now so that we don't have to multiply by anything. Do you have opposite coefficients for either one of these? No. Okay. So then the second thing you want to check is, could I just multiply one equation? Can I multiply 3 to get to negative 4 or negative 4 to get to 3?
Yeah.
No. I mean, no, not simply. You can. It's a weird number. Can you multiply 5 to get 2 or 2 to get 5 without a decimal or fraction? No. Okay. So if you can't do it to just one, then you have to do it to both. And here's where you have options. I don't care which one you work with. I feel like some people look at it and they go, well, X has a positive and a negative already, so let's just do that one because then we just multiply by a positive number. Other people are like, no, I'd rather do 5 and 2 and make one of them negative. I really don't care. Like, they will get you to the same point, so it's totally up to you what you prefer. Anyone have a preference here? Which one would you do? The X or the Y?
The access.
X. Okay, so if we're going to do X, I think this is a pretty straightforward setup. What would you multiply the top equation by? 4. Okay, that'll get you a 12x. So then we want a negative 12x on bottom. What are we going to multiply the bottom by? 3. Okay. Okay, so let's do that. Distribute the 4 to everything, and you get 12x, and you get 20y equal to what? Not 16. 4 times 6, 24. Yep. Okay, so that's the top one. The bottom one, distribute that 3 to everything. So you'll get a negative 12x, a positive 6y, and a positive 15. Okay, now stop there for a minute. Does anyone have questions about how I got there? Because that's for sure the part that gives people the most trouble, is figuring out that first thing that you're going to multiply everything by to get to a place where you can eliminate. Does anyone have a question on that? Okay, then what's our next step? What are we going to do?
24 divided by 20. Oh, wait. Oh, sorry. I already took out the X. Just take out the X.
We're going to add the two equations together, right? Big plus sign here. Okay, add the two equations together. This is 0. What do you get here? 26y equal to what? What did I do? That's not what I got earlier. Oh, I know why. Shucks. I did it the other way. I did my y's in my notes. It turned out a little bit nicer. Sorry. You get the same answers, so it doesn't matter. Okay, so this is 39. What do you do next? Divide by 26. So when you divide this by 26, people are like, I did something wrong, but it actually isn't horrible. 39 divided by 26 is 1.5, okay? So you get y equals 1.5, or if you prefer fractions, just reduce that fraction, 3 over 2. Either one is fine. Okay, Now you have 4 equations. Where are you going to plug that y in? There's no wrong answer. You can do any of the 4. Which one do you like best?
3x plus.
The 3x plus 5y. Okay, so we're going to take this and plug it in here. 3x plus 5 times what we know y to equal, 1.5, equals 6. What's 5 times 1.5? What?
4.5.
5 times 1.5.
7.5.
7.5. So 3x plus 7.5 equals 6. Divide by, what am I doing? Don't divide by 3. That would be silly. Subtract 7.5. So 3x equals a negative 1.5, and then divide by 3. So negative 1.5 divided by 3 is a negative 0.5. And again, I don't care if you leave it like that or if you want to call it a negative 1/2. Ultimately, your answer, if you treat that as a point, is the point. Hold on, it's optimizing my memory. Negative 1/2, 3/2, or if you like the decimals better, negative 0.5, comma 1.5. Why must we optimize the memory all the time? Here we go. So either one of those is great. Okay? Any questions on that? Such a big sigh. Okay, then number 5, we talked a little bit about this as we went over the homework today, right? How many solutions does something have? Tell me if your answer to a question was 9 equals 9. How many solutions would that have? Infinitely many solutions, right? This is IMS. If you had 9 equals 11, how many solutions does it have? None. No solution. Okay? If you have x equals, why are we optimizing today? Stop it. Oh my gosh, you guys, this is going to take forever. If you get x equals or y equals, it's going to optimize between every pen touch that I do. This is going to be really annoying. Anyway, if you get x equals or y equals, how many solutions do you get? 1 solution. Okay, we're going to pause this and see if we can make this stop. Okay, so number 5 here says, how many solutions does the system have? Oh, I took that with it. What are we going to do? First of all, technically, you could do substitution or elimination here. I'm going to do elimination since that's the focus of this lesson, but you could do either. And on the quiz that you'll take next, which is next week on the block, I let you do either on the, is it the word problem one? I don't know. I make you say, like, solve this by substitution, solve this by elimination, but then I give you the option on one of them too, okay? So if we're going to do elimination, what should we multiply which equation by?
The bottom one by -2.
The bottom one by -2 would be fantastic. So I'm just going to copy that top one and move it over. You're welcome to rewrite it if you want, except that it didn't do it. Oh my goodness. Okay. So there's your top equation. The bottom equation, you're going to distribute that. So it's going to be a negative 2x. This was a positive 2x minus 6y equals a negative 18. What do you do next? Add them together. Okay. What do you get when you add 2x and negative 2x? 0. What do you get when you add 6y and negative 6y? 0. So here's the thing. If everything on one side goes away, you got to put a 0 in there, right? That's equal to 0. What do you get on the right side? 0. If 0 equals 0, how many solutions do you have? Infinitely many solutions, right? IMS, infinitely many. If it is true, 0 equals 0, 9 equals 9, a million equals a million, infinitely many. Okay? Questions on that? Okay, last thing. This one says the theater club sells a total of 101 tickets to its first play. I should have turned this into a winter formal dance ticket thing. It wouldn't work on this very well. That's okay. Student ticket costs $1. An adult ticket costs $2.50. The total ticket sales are $164. How many student tickets were sold? Set up a system and solve it. Okay, so here's the thing that I think people struggle with the most on these types of problems. There's two things going on, right? There's a quantity, there's a number of tickets being sold, and there's also a value of the tickets being sold, money, right? You have to keep those things separate. You got to keep the money together over here and the number of tickets together over here. Okay, so you're going to write two equations. Can anyone tell me the equation that we would write? By the way, you should always define your variable. We're going to call A our adult tickets, and we're going to call S our student tickets. Okay, can anyone tell me the equation for the number of tickets sold? What will you write?
A plus S equals 101.
Yes, there are a total of 101 tickets. So it's adult tickets plus student tickets is 101. Okay, so that's one equation. That's dealing with the quantity, the number of tickets. There's another equation that deals with the value of the tickets. Can somebody else tell me that equation? So 2.50A. Could you write that as 2.5A?
Yeah.
It's the same thing. You could. So 2.50A plus what? $1 per student ticket equals 164. Okay, so keep the money together, right? All of those are dollar signs. $2.50, $1, $164. Okay, now, if we're going to do elimination, is it ready to go? Yes and no. If you were going to subtract them, sure, it's ready to go. We like to add them, right? So I'm going to add them together. So what are we going to multiply by? -1 would be a good option. So I'm going to multiply this one by -1. So it'll be a -1A minus 1S equals a -101. Okay, so I'm just ignoring that top equation right now. And now we're going to add them together. Okay, 250 plus a -1 is 150A. This one becomes 0, right? 1S minus 1S is 0 equals, and this becomes 63. And then divide by 1.5. 63 divided by 1.5 is 42. Okay, now here's where I see a lot of other mistakes. What does that mean? 42 adult tickets, not $42 per adult ticket, right? They told us the cost. This is how many did we sell. So 42 adult tickets. So are we done? No, what did they ask us for? They asked us for the student tickets. So if there are 42 adult tickets, then we're going to I would take that original equation, right? 42 plus the number of student tickets equals 101. So take away the 42. And S equals 59. That means there were 59 student tickets sold. Does that make sense? Yeah. How do we feel about elimination? You like it? I like it. Okay, here's my other question then. Do you like elimination better or substitution better? Who likes substitution better? 2 of you. Who likes elimination better? A lot more of you. Does anyone like graphing the best? No.